Hey everybody, another video today. We're going to be going over our fuel tab. So this is based on the FOME firmware that all of the classic daily ECUs handle. So this basic theory will apply to any ECU. If you're needing more information about the setup of your ECU, check the base tune or go back to one of our earlier videos. We'll explain it. So we talked about the base engine. In the last one, we're going to talk about fuel. I am not going to go to every single tab in here because there's a lot of stuff and it will take a long time to cover, and we'll explain some more in some shorter videos. But this is just a general idea of what's going on in this video, in this one. Okay, so injection configuration. This is going to be where you're actually setting up the injector information for your engine. So we want to have this on. So the nice thing about this is you can turn it off. So if you're just cranking the engine and want to check some other things, you want to turn fuel off, or you can click that, go to off. I'm not going to spray any fuel. Okay. In these different modes, sequential, simultaneous, batch, single point, what sequential is doing is it's doing one injection of fuel over the revolution of the full cycle of the engine, 720 degrees. Batch is going to spray twice the cycle, and then single point would be just like a throttle body style. Simultaneous is going to spray all the injectors all the time. We're going to leave it on sequential. It's not necessarily sequential, and we'll talk about that in a second. Okay, we're going to go right over this stuff because it's we don't need too much of this information for what we're trying to explain with the basic setup of your car and understanding each of the pages. So this would be CC, the size of your injectors in CC. Okay, we'll leave this as volumetric flow. Then we can do, if you have a fuel pressure sensor or a setup, you can have it adjusting some things in here based on the rail pressure. We're just going to leave this at none. So if you have a sensor setup, it will adjust fueling based on the pressure that you want and as it changes. Okay, so we're leave that for none for now. This would be the stoichiometric ratio of the gasoline that you're running. 14.7 is going to be with straight gasoline with no ethanol in it. So if you do have a flex sensor and you look at it and you're like, oh, why does it say it's not what I told it? It's because pretty much all pump gas now does have some ethanol in it. This is grayed out because the sensor in miscellaneous sensors for our flex fuel is turned off. If I turn that on, it's gonna see, you'll see now that this is lit up. So we'll leave that on for now. So then it lights it up. This information right here, there's going to be your dead times for your injectors. These are very important. If you have injectors from a company, get the dead times, put them in here. If you can find dead times for your stock injectors, put them in here. If you can calculate the dead times, do that. This is going to make your life a lot better, a lot easier. If you ever change injectors, if you have a flex sensor, the dead times are going to be huge because the ECU is going to know how the injectors are working. Okay, we're going to close out of here. We'll go to injection hardware. This engine is set up as a 4-cylinder, which we saw over here in base engine, 4-cylinder. If I change this to a 5-cylinder, it's going to change that there. So it's a 4-cylinder. This tune is set up for an M42. There are only 2 outputs for fuel. So you're going to put all the outputs in here, or however many outputs you have for your engine is what you're putting in here. The ECU is going to do all the other hard parts where it knows which ones to fire. You don't have to tell it that you only have 2. You're doing it right here. Tell the outputs, and it's going to do the rest. Now, if this was a 4-cylinder with 4 injectors, you would have, or 4 injector outputs, you're going to put them all in here. This is a 4-cylinder with 4 injectors, but it only has 2 outputs, so they're wired together in batch. Injector test. This is kind of neat. So you can actually test the injectors. You would key on. You're going to hit the injectors that you have wired up. In this case, it does show all 4, but we know there are only 2 wired, as I just explained. and then it will actually fire the injectors. We'll click them off 3 times for a length of, for however long you set up in this setting, and it's going to let you hear the injectors and make sure that they're actually wired and firing. We're going to skip over a couple spots here. Stage injection would be if you had more than one set of injectors set up. We're not going to worry about that. Fuel trims. So if you do have the feedback where you can trim the fuel out for each one, you can do that here. Again, we're not talking about all about that right this second. We are going to talk about VE because this is important. So the VE, this is going to be your RPM on the X, and this will be load on the Y. Now your load here is going to be based on whatever you set up as your fuel strategy here. Speed density is what we have set up. So this is going to be KPA. In this case, it only goes to 100, so it's a naturally aspirated engine. This is all vacuum. So if we had a boosted engine, this would go up to as high of boost that you plan to run and that your map sensor can handle. If you were in Alpha N, this would be TPS from 0 to 100. If you were in MAF air charge, this would be it's the filling of the cylinder. So this would be like a 0 to 150 or something in that range. Again, we'll cover that in another video. But this is actually the volumetric efficiency of the engine. It should never get over 100, even in boost, as long as your injector data is correct. If the injector data is wrong, if your fuel pressure is wrong, then these numbers will look wrong. Okay. I'm going to show you a real basic idea how to build a table. So anytime you're building this, you want it to be smooth. Smooth is your friend. So for the sake of this, we're going to go and make it 0. Okay. And this area down here is your idle. So I'm gonna just blanket this. So if you have a base tune, you shouldn't have to do this, but this is just good information. I'm gonna blanket this at we're gonna go 75%. So that would be 75% efficiency. We're gonna go up to the top here, and we're gonna blanket this at 95%. And that's pretty optimistic for an engine to be that efficient, but who knows? We're gonna take this area and we're gonna make this 80%. And then what I do is I'm going to drag and pull these over. And then you can, depending on what version of Tuner Studio you have, if you have the paid version, you'll have this interpolate key, and this is going to go vertical. You click it and it's going to smooth all the way through there. And this, you can do the same thing like so. And then I would usually yank, to here-ish, smooth, and we should get a pretty flat, smooth looking VE table. Okay, this should run, the engine should run on this, and then you're going to adjust things as needed, as the engine wants. Give it what it wants. They're all different, everyone's setup is different. Give the engine what it wants, make it run. Okay, if these numbers are way skewed out of range, like you're seeing 200 kPa or 200 up here, something's wrong, and you should be looking at fuel pressure. You should be looking at your injector data. Maybe that's wrong that you typed in there, but for the most part, give the engine what it wants, okay? Unless the numbers are crazy, and then fix the problem. Don't just keep tuning around it, okay? So we're gonna close out of that. Blend tables, we'll talk about that in another video, but these are super powerful things, and they exist in fuel, ignition, and boost control. We're not gonna worry about that now, another video. We're not gonna really worry too much about any of these other settings either. Again, I'm trying to give you the basics of this, and we'll have some more videos where we talk about all the things, or if you want to dig in. Excuse me. Target AFR, as I mentioned in a previous video, the ECU does work in Lambda, but it converts over to AFR. So if your brain works better in AFR and you're not using flex fuel, use AFR. If you are using flex fuel, if you're using a flex fuel sensor and you're adjusting it at all based on the blend in the tank, you must use Lambda. Okay, use Lambda. So we're gonna switch that now, so we can go. Let's see, where are we? Sorry about that. So it's going to yell at me because it saw it's converting from AFR to Lambda. We'll just ignore that. Okay, so we go to target Lambda. Now we have a single number. Lambda is 1 is going to be a clean burning engine. However, for whatever fuel it is, whether it be pump fuel, whether it be E85, whether it be methanol, whether it be E10, E20, E40, whatever is in between is that. So it is a better method to use, especially if you are using flex fuel. If you're using flex fuel, 100% make sure you're using Lambda. So in case you see down here, we're at about 1 Lambda, and up here we're at 0.78 Lambda, which will be a richer mixer. So this is the actual ratio of air to fuel in the engine. Okay, so that's our target Lambda table. And again, give your engine what it wants. And I can't explain everything because I don't know what your engine wants. Okay, so we'll go to CLT multiplier. So this is going to be coolant temp multiplier of your VE table. So this would be when you are colder, it's going to be richer. So a number of 1 is going to be exactly what that VE is. If we put 0.95 in here, then it's going to multiply your VE by 0.95. If it's 1.23 here at 10 degrees Celsius, it's 23% more fuel over your base VE table. So this is how your warm-up enrichment. So when the engine's cold, the fuel isn't atomizing the same way, and it's sticking to the intake manifold, and the engine needs more fuel. So you're going to give it more fuel here. So as you're tuning, I dial in your warmed up temp all the way, and then start adding fuel based when you're colder. Play with this warm up fuel multiplier. Same thing with IAT. You can, if it's warm, if it's cold, air temperature, you can adjust it there. That's all set to just 1 flat. All right. Okay, closed loop fuel correction. And this is what's awesome again about this firmware is that it has phenomenal closed loop fuel correction. And you can have it so it's different based on the main region, the idle region, the power region, overrun region, anything. And this is all very adjustable. Okay. It's pretty self-explanatory. Startup delays would be at 20 seconds. So when you start the thing up, let your oxygen sensor warm up. This might be even a little bit low. This would be if you're at low temperatures, you maybe don't want correction to happen until the engine's warmed up. Having these numbers in here will eliminate if you have a sensor that fails or something and it's pegged, or if you're on overrun and it's actually shutting fuel off, it's not gonna keep adding fuel. That's what those are for. And then this kind of is where you base it. You set your regions for idle, overrun, and power. And then here would be all of your different settings for actual fuel correction. The first thing where it's time constraint, what it's trying to do is it's trying to take 2 seconds to adjust the fuel. So it's looking, in a sense, backwards 2 seconds to then adjust fuel, adding or removing to get your target lambda. And this can be a smaller number if it will mean faster, but you're probably going to feel it if it's a really low number and it's a lot of processor power. Okay. Deceleration fuel cut, it's on. What this does is when you let off the throttle, it's going to cut all sort of fuel. So this would be on overrun. So like if you're 5,000 RPMs and you let off the throttle and you clutch in, or even don't clutch in, and it's coming down, it's going to cut fuel so you don't have just lets the engine kind of shut off for a little bit, and it saves fuel. It's not dumping fuel. You're not popping and banging as much. And there's so many different settings in here based on, again, what your engine wants and how you want it to react. So this can be, if your RPM is above 1900 RPM, it's going to cut, and it's going to wait to 1700 RPM to re-enable. Okay. And you can look through all these different settings to adjust as needed. So down here as well, we have acceleration enrichment. Acceleration enrichment is going to be when you stab that throttle and it's a transient from anything, and the VE can't really necessarily keep up. It's going to give it a little bit of extra fuel. Okay, this length and second, this is how it's looking backwards in time. It's looking at what you've done with that pedal, and that's going to affect how that extra injection is. Okay. So this table here, TPS over TPS acceleration extra fuel, This is in milliseconds. So if you have huge injectors, these numbers are going to be small. If you have small injectors, they might be bigger because you're adding more fuel to keep up with the engine when you stab that throttle. This is really needs to be adjusted driving the car, and it just probably takes some of the most time to dial in. And then we have some other settings in here, which we'll go over in another video because the videos get too long, and we're trying to give you all the information as we can. So that's the fuel table. And the next one we're going to go over is ignition. So that's spark, and then we'll continue on through. So if you guys have any questions, please put in the comments, send us an email, head over to the FOME Discord, letters, carrier pigeons, whatever you need to do, but let us know. Thanks a lot for watching, and catch you next time.